All right, so in section 12.2, we did measures of central tendency. So these were supposed to be measures that gave us a sense of the average or most representative, a number that was representative of the center of the data set. Okay, and that was mean, median, and mode. And then with section 12.3, we did measures of central tendency, measures of dispersion, okay, which was a fancy word for the spread of the data set, so kind of how far apart the data values were. So these were range and standard deviation were the two we did. Okay. So if you looked at taking, say, the mean, that number together with the standard deviation, it would give you a good sense of the distribution of the data values, how spread out they were and how big they were on average. All right, what we're doing in section 12.4 is something called a measure of position. So it's really giving you a sense of how a particular data value compares to the other data values. Like, where is it located in the data set as compared to all the others? Okay. So measures that do that are called measures of position. And there's just two that we're going to really look at, right? So the big one, the one that we're going to spend a lot of time on, is a z-score. So it tells you how many standard deviations above or below the mean a particular data value is. So that's called a z-score. Okay. Right, the other one that we'll spend just a little bit of time on is called a percentile. So these, you may have experienced these if you took a lot of tests through your school, through K-12, large standardized tests. Sometimes when the score reports come back, you don't get your raw score, you get what's called a percentile score. Okay. And so, like, if they tell you that your score was in the 83rd percentile, that's different than saying you made a 83% on the test. 83% would mean that you got 83 out of 100 questions correct. 83rd percentile means that your score was greater than 83% of the scores. So the raw score was greater than 83% of the scores. Right? Other measures of position are things like deciles and quartiles. We're just not spending much time on those, or any time on those. All right, the median really is a measure of position, and it's the same as the 50th percentile. It's right, because to find the median, you look for that middle value, which would be greater than 50% of the scores. All right, let's look at z-scores in more detail. Here's the formula for it. And in the formula, the x bar is the mean, the s is the standard deviation of your data set, and then the x is the individual data value. And remember, what you're trying to do with measures of position is give a number that that tells you where that particular data value falls as compared to all the other data values in the data set. Okay? So a z-score really is the number of standard deviations. So a z-score really is the number of standard deviations above or below the mean. So it's the number of standard deviations above or below the mean that the data value is. Okay. So if the data value is less than the mean, then the z-score is going to be negative. If the data value is greater than the mean, it's going to be positive. So positive if the data value is greater than the mean, negative if the data value is less than the mean. Okay. It's a good way to compare relative positions of items when you have two separate data sets. Okay. All right, let's first just work on using the formula to get your z-score. So this is going to become important because we took a look at the z-score table already. So to use that table, we don't use a raw score in the data set. We use something called a z-score. So if we had a raw score that was 133, we could convert it into a z-score by using that formula. So the z-score would be found by taking that raw score, subtracting the mean was 125, so that right there is your x bar. The standard deviation was 5, so that's your s. So then you divide that by the standard deviation, which is 5. Okay, and order matters. You need to be sure that you put your data value first, okay, because the sign of the z-score tells you whether you're above or below the mean. So now if you subtracted 125 from 133, you'd get 8, and 8 divided by 5 is 1.6. You typically want your z-score actually to be 2 decimal places. So I really should have said to the nearest hundredth, because to use the z-score table, you look at numbers that are to 2 decimal places. So it really should have said hundredth there, just to get you in that habit. Okay. All right, now let's suppose we have a different raw score that's 100. Let's get the z-score associated with that. So the data value is 100. We take away the mean. We divide by the standard deviation. So this time we're getting a negative number. Got negative 5. Okay, and that would be 5.00. So that would be very unusual for that to happen. Okay. All right, now over on this page, we're looking at a situation where these two students are in 2 different history classes that had exams on the same day. So Jen made a raw score of 83. Okay, so Jen's score, let me get that in here. Her raw score was an 83. Let me just put it above her name. And Joy's raw score on the test was a 78. It says, the question is, which student did relatively better given the class data shown below? So Jen made a better grade on the test, but these were 2 different history classes. So really, maybe the test in Joy's class was just way harder, or maybe there was some other factor that affected her score on that test. So when they say relatively better, we can look at how Jen did relative to other people in her class and compare that to how Joy did compared to the other people in her class. All right, so let's take Jen's situation and let's get the z-score that corresponds to her raw score of 83. Sometimes you use subscripts to just keep sense of what you were doing. So the z-score corresponding to Jen's score of 83, we would need to use the data for Jen's class. So we'll take her raw score, subtract the mean, and divide it by the standard deviation for her class. Okay, so that turns out to be a 5 over 4, so that turns out to be 1.25. Now let's do the same for Joy. Let's get the z-score corresponding to her raw score of 78. With my z's, I usually put a little line on them because they can look like 2s if I don't. So her raw score minus the mean for her class divided by the standard deviation for her class. So hers was 8 over 5, and 8 over 5 equals 1.60. So that z-score being 1.60 means she was 1.6 standard deviations above the mean, where Jen was only 1 1/4 standard deviations above the mean. So Joy did relatively better. Than the other students in her class as compared to Jen. Okay, now let's look at percentiles and try to make a little more sense of that. All right, so we mentioned already if you had, so if we had a percentile score that was like the 83rd percentile, then that means that approximately 83% of the items would be less than your raw score. We don't know what the raw score would be, but we know 83rd percentile means your data value was better than 83% of them. Okay, so think about that. So 83rd percentile was that example we did earlier. So the data value would be greater than 83% of the values, of the data values, okay? All right, so let's see how to handle this. So what happens on this, there's one little tricky part that you need to watch out for. Sorry, let me try to get that lined up like I want. There we go. All right, so here's the tricky part. So you're going to do, like for the 40th percentile, okay, that you're going to want to take and find out where you're going to want to do 40% of the number of data values so that you can then count to try to get the data value that's in the spot for the 40th percentile. So you need to do 40% of the data values. So here there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 24, 25, 26, 27, 28, 29, 30. There are 30. So do 40% of 30, and you do that by taking 0.40 times 30, and that gives us 12. You need to go to the 13th one. The 13th one, so that you're going to the score or the data value that is better than 40% of them. So better than, is past the 12th one. You have to go to the 13th one. This is the piece that sometimes people forget. You have to go to the next one. All right, now the data values would have to be in order. These already are. So I'm going to count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's the 12th one. So the answer to this question would be the 13th one. So P of 40, okay, the 40th percentile would equal 75. 75 is in the 40th percentile. Okay. All right, now there's a problem like this in the text, and I just wanted to kind of go through this. Right, it's percentiles with such small numbers of data values are a little strange, but we're going to do it anyway. For this, you need to be careful when you do your reading. Okay, so on this one, we've got this chart that has various different information in it. So we got population, production, and consumption for 5 different countries. All right, so we're supposed to determine the country that would be in the 25th percentile in terms of population. Now there's 5 countries, right? So 5 data values, 5 countries for each. So we're going to do 25% of 5, which would be 0.25 times 5, and that's going to give us 1.25. Okay, so we're going to go to the next. So remember this piece right here. This right here is important. Okay, so then select the next greater whole number position. So go to 2. Then you look at which country is in the second position in terms of population. Okay. They have to have done better than 1.25, so whatever country's in the second spot would do that. Okay, so you go from Canada, then Russia. Okay, so that would be Russia. Let me write the answer over here to the left. So the answer would be Russia on that one. Right here we want which country would be in the 75th percentile in terms of consumption. So we're going to do 0.75 times 5, and that gives us 3.75. So the 4th one. So that one was the second one. This one is the 4th one. Next whole number. Okay, and we got to go to the consumption table and we got to count up. This would be 1, 2, 3. That would be the 4th one. And so that one would be the US. Okay. Right, and then on C, we're doing 20th percentile in terms of production. So we're going to do 20% of the 5 data values. Here we get a whole number. I wanted to do one like this because you don't go to the first one, you go to the next whole number. So second one. You should be looking at the production table. So that's 1, 2. So that would be here, and that would be Canada.